G'day YouTube, Warbles on a lot here. Those of you familiar with the channel will recall that 4 days ago I conducted and videoed and posted the clip of a load test that I put these batteries through. A pair of 225 amp hour capacity rated 6 volt cells which have done their time in a golf cart. The drill sucks 10 amps out of the batteries through the power on inverter. So whereas I hoped to run for about 5 minutes, I only actually ran for 2.5 minutes, and I only actually sucked about 1/3 of 1 amp hour out of the batteries in order to run the drill. And the theory with this battery resuscitation game goes that after you get the batteries as fully charged as you can possibly get them, then you're supposed to discharge them by as much as 10%. And then charge them up again. And the theory is that in discharging, you will initiate the reaction occurring on the plates, which is exposed to the electrolyte, and that reaction will sort of work its way in through the edges of the plaques of lead sulphate, which have over the years accumulated on the battery plates because of improper battery maintenance and wrongful use cycles. That's kind of the theory. So whereas the resting voltage in the mornings had come down 12.62, 12.61, 12.61, all the way down to 12.5 volts before I applied the load test, it's interesting to see 13.63 at 0.35 of an amp at 25 past 4. Next morning 12.55 volts, cloudy day 13.11 volts at 20 to 7 at night. Next morning 12.65 volts. Another fairly cloudy day 13.09 when disconnected. Next morning 12.65 volts. Pretty good sunny day yesterday. 12.95 volts at 0.01 of an amp when disconnected at 12 minutes past 7 at night. This morning, be buggered to the wind, 12.61 volts. Okay, so clearly it is now time to apply another load test. So having applied a sunshade, in order to be able to zoom in and actually read the instrument displays on all 4 of the implements, and having zeroed the amp meter, it will be time there we go, loose connection, 0.75 of an amp, 13.16 volts. And let's run this thing for a period of 5 minutes. Starting from now. Well, that's 2.5 minutes, and it's almost a full volt above the reading after 2.5 minutes 4 days ago. Three minutes into the test. Four minutes, 10 seconds. Five minutes. Five, four, three, two, one. And that was 1 amp hour with a 0.01 of an, maybe 0.1 of an amp error factor at 6 minutes to 11. 5 to 11, 12.23 volts. So in a minute I'm going to connect up these two 10-watt solar panels, which together produce 2.1 amps. So if we allow for 10% losses to heat, I'm able to pump 2 amps back into the batteries, which have just delivered 10 amps for 6 minutes, or 1 amp hour. So in theory, if these two panels were in full sun, which they're not quite actually yet, because the sun hasn't moved out from over the wattle tree. Here we go. 12.35 volts. And we apply the panels. Voltage jumps to 12.6 and then starts coming back down. 0.95 of an amp through one panel. Plus 0.54 1.53 of an amp from the other panel. So we'll call that 1.5 amps, 12.6 volts. As from 2 minutes past 11. So in theory, either one of these panels in 1 hour of full sun makes enough current going into the batteries to run that drill for 6 minutes. And remembering that the drill was doing no work, it was merely rotating. If you were actually drilling holes, you would need 3 of these panels for an hour to run the drill for 6 minutes. But anyway, I'm going to jump cut ahead to midday and we'll see what we've got there. Okay, back again at the advertised midday with a cloud in front of the sun showing 13.7 volts. 0.13 plus 0.1718, 13.61 at 0.3 of an amp, which would be a bit discouraging if it were not for the fact that we've already seen 14.2 volts at 1.95. And it's come up pretty well in the past hour. And now 12:07, as the cloud begins to depart from the sun, 13.85, 1.05, 1.03, plus 1.13, 1.15, 2.2, coming down through 14.05. By use of the humble alligator, I have averaged the figures for the past hour, and we actually put 1.33 amp hours back into the batteries, which had produced 1 amp hour worth of current to feed the inverter, to feed the power drill, to run it for 6 minutes at a 10 amp average drawdown in, the limits of my instrumentation. So either the batteries have only got 70% storage efficiency, or they're running at closer to 85 or 90% storage efficiency, but each time I'm cycling them, around about 5 or 10% of the energy is going into basically shaking the lead sulphate off the plates and thereby exposing more of the plates to the electrolyte and thus gently restoring the active storage capacity of the old batteries. At least that's the theory. And as yet, haven't yet reached 14.5 volts, which is where I would think about disconnecting one of the panels to prevent from overvolting the system. And as usual, the proof of the pudding is in the eating. So we'll find out what happens tomorrow morning. But in the meantime, with a sky like this, I'm just going to see how much more power I can drive into the battery. Warbles on a lot to YouTube. Ciao.